All right. MA 106, skill number 5. We're moving right along. We're still in the geometry chapter of the book. We've gone through various sort of perimeters and areas, polygons, circles. We did sort of an application in skill number 4 with linear and angular speed. And what we're going to do now is add another dimension on. So perimeters, right, is sort of a one-dimensional thing. You're just measuring the distance around the edge. But, in the end, it's a one-dimensional measurement. It's either, right, inches or centimeters or feet, miles or something. We went from there to areas, a two-dimensional measurement. So taking up sort of two-dimensional space, sort of a length by width. Obviously, a little bit of a different formula for circles, pi times r squared. That gave us squared units because you're sort of talking about two different dimensions. And so if we're going to extend this a little further, what we get next is volume. So if we sort of extend into 3 dimensions, so not just sort of like a left, right, and sort of a backwards, forwards, but also like an up and down. This would be sort of what you would think of as sort of an X, a Y, and a Z axis, if you're thinking in terms of sort of graphing and algebra kind of stuff. Three-dimensional world is also just sort of the space we exist in, right? You can go forwards, backwards, left, right, and up and down, right? So you can sort of have these 3 different dimensions you can sort of move through, and thus all the sort of shapes and things we encounter are 3 dimensions. Even something like a sheet of paper, which you would think of as, for the most part, kind of a 2-dimensional thing, right? Sort of a length by width because it's so skinny. Technically, there's a volume there, right? It's just like a very thin, right? Paper is very thin. So what would be sort of the height dimension is very tiny in any event. In general, so we're going to be looking at either what we would sort of call prisms. So a prism is a 3-dimensional shape where your sort of base shape is some sort of polygon. So that would be right for us. So a triangular prism would have a triangle on the base, and then it would have a height value, or rectangular prism, which is sort of what we have in this picture here, with a sort of a rectangular base, and then you have some sort of height coming out. Or if we just have what we'd sort of generically think of as a cylinder, cylinders, which of course show up in the engines of cars. Those are 3-dimensional figures where the base is a circle, right? Circular base. In theory, right, you could do all sorts of things. I sometimes think of almost like cookie cutters, right? You could have sort of star shapes. A cookie cutter is kind of like a short cylinder, right? It has a particular sort of base shape that you're cutting into the cookie, and the cookie cutter itself has a certain amount of like height, obviously to sort of go through the cookie and leave space for the dough. In any event, rather than come up with however many sort of new different sort of volume formulas, what we're going to be using is kind of a generic volume formula. So for us, volume is going to be whatever the area of the base shape is. So we'll just be kind of reusing what our sort of rectangle area, the rectangular area formulas are, or the circle area formulas, the triangle area formulas, trapezoid in theory, but we're not really going to see any trapezoidal prisms. It's that base area just times the height. It's a relatively kind of simple concept if you're thinking of area as sort of length times width, right, in the most sort of basic sense. Then a volume is sort of length times width times height, just sort of times whatever the height value is, that sort of 3rd dimension. What happens here, right, is our units now go from what would be sort of squared units in an area. They become cubed units or cubic units when we're talking about volume, right? So this for us here, right, cubic inches, inches cubed, cubic centimeters, centimeters cubed, cubic centimeters, also sometimes referred to as cc's. We're going to talk a little bit, right, because cylinders are in the engine. The size of the cylinder is directly related to the size of the engine, right? And so sometimes for smaller engines, you're measuring them in cc's, which literally are cubic centimeters. It's literally the volume of all the cylinders in your engine. In any event, let's just sort of run a couple quick volume examples. Nothing super wild, just sort of given a shape, using our sort of the area formulas that we know, multiplying by the heights, and we'll go from there. So the volume, find the volume of a rectangular prism where the length is 6 centimeters, the width is 3 centimeters, and the height is 20 centimeters, right? We can kind of mark some of these values here. We have a little sketch. So what do we say? The length is 6, the width is 3, and our height is 20. As always, the sketches are not perfect, right? They're not always sort of drawn exactly to scale. We're sort of doing our best here. So what do we need? Well, the volume, right, we sort of said in the generic sense is going to be the area of the base times the height. So the base area, right, is going to be length times width. That's our area formula. So that would be 6 times 3. So that's here, 6 by 3. We have our units here. Technically, the two of those, right, would sort of get us to 18 centimeters squared. And then all we're doing from there is just multiplying by the height value, right? This is my height. So 18 centimeters squared times 20 centimeters tall, right? 20 centimeters is the height. Is going to get us 360 cubic centimeters. So length times width times height. Bingo. There we go. Different shapes obviously will have slightly different calculations. If we did a cylinder, for example, right, the second example here from the book. So find the displacement, which would be the volume. Let me do a book example first. I'll come back to that displacement. We'll have that displacement video. So say we look at maybe number 6, right? So find the volume of this triangular prism where the base of the triangle is 13. The height of the triangle is 7. So there's a little bit of a language thing here, right? We need to sort of watch, what is the base value of the sort of triangular shape on the bottom. What is the height of the triangle versus what is the height of the prism? So the height of the prism is 15, the height of the triangle is 7, and the sort of base of the triangle is 13. Let's sort of make a little sketch of this for us to use as a reference. So let me kind of remark where we are. Let's go number 5. Problem number 6. So my triangle base was what, 13 centimeters. My triangle height, this is sort of a wide, sort of squat one, was 7. And then the prism height was 15. So just to try to get a little bit of a visual going, and these are of course a little sort of tricky to draw. So we have sort of a wide triangle here. It's maybe a little bit sort of less. So this is what, 13 centimeters going across. The idea is we have kind of a height value here. That was what, 7. And then this is 3-dimensional, so all of these are heading up, right? So we're getting something kind of like this, right? And so our height here of the prism is 15. So my volume is just going to be my sort of triangle area times this prism height. Triangle area, of course, that formula we all know and love, 1/2 base times height times the prism height, which is 15. Again, the only real trick here is just we have to keep track of, right, which is the height of the triangle versus which is the height of the entire prism. So 1/2, we said the base right, is 13 times the triangle height was that 7 times the 15 that we had out here. Gosh, what is this going to be? I don't know. Off the top of my head, we'll just crunch it. We'll try to get too fancy. Right, I'm going to do 13 times 7 times 15. Whoops, 13 times 7 times 15, not just times 1, right? And then, you know, times 1/2, we can think of this as just sort of dividing by 2. So 682.5. And my units are cubic centimeters, right? So just using this kind of stuff. So rectangular bases, triangle bases. I'm going to save that cylinder one for the next video. So why don't I pause now, and I'll see you in the next video.